How you guys doing? This is Mobile 12 speaking. For this video, I'll be discussing and going over how to calculate the formal charge for a specific atom in a molecule. Okay. Some of your teachers or professors in your general chemistry classes may have taught you guys a certain way, a very long formula, but I'll show you guys a simple technique I've learned from professors and friends. So hopefully this video is going to be nice and short and to the point. So let me give you the easy formula that I've come across. Okay, all it is basically your valence. Okay, hold on a second. Oh, it's dried up on me right now. Okay, your valence number, okay, minus the amount of bonds you have connected, okay, bonds connected to the atom, okay, plus lone pair, okay, LP for lone pair electrons around the atom. Okay, again, so it's basically the valence number of the atom. This is all specific to the atom, okay, that you're trying to calculate the formal charge for. So the valence number of the atom minus the sum of the bonds connected to the atom plus the sum of the bonds connected to the atom and the lone pair electrons on the atom. Okay, so that's the formula. So let's work on some problems, and then once you get the hang of this, you start to recognize some trends. For example, when you start doing so many calculations, you'll realize that if you have three things attached to oxygen, it will have a positive 1 charge. If you have one thing attached to oxygen, it will have a negative 1 charge on oxygen. So you start to get the hang of it and realize some trends. So let's look at some examples. So for example, let's look at an easy one, methane. Okay, so C with one H here, another H here, another H there, another H there. Okay, so this is methane, right? So let's calculate the formal charge on the carbon. Okay, again, the formal charge is specific to the atom, each atom in the molecule. So so let's start. Okay, the carbon has a valence number of 4. Okay, how can you find the valence number? It's pretty simple. Let's see. Let's see if I can find a periodic table for you guys. Okay, for example, here's a periodic table. Okay, let me zoom in on this right quick. Okay, I'm gonna just tear this apart. Okay, here's carbon right here. There's carbon right there. Okay, how do you know what the valence number for each atom is? It's simple. Usually we focus on atoms, usually the non-metal atoms, which are over here, and the metal atoms here. The transition elements we don't really focus on, but it's pretty simple. For example, carbon has a valence number of 4. How do we know that? Well, we just count the columns and we just skip this main column over here. Okay, and valence number is the amount of electrons in the outermost shell. Okay, so 1, 2, 3, 4. Okay, again, we skip this major group here, the transition elements. So we start from here, from the first column. So 1, 2, 3, 4. That's the valence number for carbon. Let's move on to oxygen. Again, start from here. 1, 2, 3, 4, 5, 6. The valence number for oxygen is 6, and all the valence number is saying, it's saying that there's 6 electrons in the outermost shell for oxygen. Let's try sulfur. Again, we start from this column here. 1, 2, 3, 4, 5, 6. That's sulfur right there. So sulfur has a valence number of 6. Pretty straightforward. Okay, so as you realize, carbon has a valence, oops, let's zoom out a little bit now. Carbon has a valence number of 4. Okay, so it'll be 4 minus the sum of the bonds attached to the carbon and lone pair electrons on the carbon atom. Okay, so the carbon has 4 bonds, right? 1, 2, 3, 4. Okay, so there's 4 bonds, plus how many lone pair electrons are on the carbon atom? There's 0. So put a 0 there. So it's 4 minus 4, which equals 0. So there's a formal charge of 0 on carbon, okay, in this methane molecule. Now, pretty straightforward. It should be pretty easy. You guys should get the hang of this. Let's go to hydrogen, and then I'll give you guys a pretty tough example, and that will conclude our discussion on formal charge calculations. So hydrogen, okay, so let's see, okay, hydrogen, what is the valence number for hydrogen? It is, again, if we look right here, there's our hydrogen atom right there. It's in the first column, so it has a valence number of 1. Okay, so we put 1 minus the amount of bonds attached to the hydrogen, so 1, plus the plus the lone pairs on hydrogen, so it's 0. Right, there are no lone pairs on the hydrogen atom. So again, there's a formal charge on the hydrogen of 0. Okay, there's no formal charge on there. Okay, so let's look at one tough example. Okay, so let's look at this molecule right here. Okay, this is our final example. Let's do this also here. Actually, I will leave that alone. Okay, so let's look at this example right here. Let's go. So I'll circle the atoms which need a charge around it. Okay. As you guys start to get a feel for this, you guys will realize and recognize atoms without the professor specifying which atom needs a formal charge. Okay, so in this case, this atom right here needs a charge. Excuse me, not needs a charge, it has a charge, which I haven't specified yet. And this atom right here has a charge, which I also haven't specified yet. Okay, so let's look at this atom first. Okay, so again, oxygen is right here, excuse me, right there. It's in the 6th column. So it has a valence number of 6, so we write that down here. 6 minus the sum of the bonds attached to it, so it's 1, excuse me, plus the sum of the lone pair electrons around the oxygen atom. Okay, so there is 1, 2, 3, 4, 5, 6. There's 6 lone pair electrons. Okay, so the answer to this little addition problem is basically -1. Okay, right? So 6 minus 7 is -1. So this oxygen atom has a formal charge of -1. Okay, so usually we don't put the -1, we just leave a negative around it. Okay, so that's the first one. Okay, now the nitrogen atom, let's look at that one. Okay, nitrogen, the valence number, okay, it's right next to carbon, so it's in the 5th column, right? So it's 1, 2, 3, 4, 5. So it'll be 5 minus the sum of the bonds around it, so it's 1, 2, 3, 4, plus lone pairs. So there are no lone pairs around the nitrogen atom, so we put that as 0. So this is equal to +1. So that's the formal charge around the nitrogen atom in this molecule. Okay, so it has a +1 charge. and usually we just omit the 1 and just leave a positive, assuming that there's a 1 next to it. Okay, so there you go, there you have it. This is the way of calculating. This is actually a very easy and quick way of calculating the formal charge for atoms in a molecule. Hopefully this all made sense. For the next video, I'll be discussing some other stuff that revolves around the first semester organic chemistry. Again, I'm spacing my videos throughout all of chemistry. I'm doing inorganic chemistry, organic chemistry, first semester, second semester, so I'm all over the page. So stay tuned to the next series of videos. I'll probably be discussing some stuff on naming alkanes and Newman projections. So thank you for watching. This is Mobala 12 and I'm signing out.